March 16, 1942. 400 kilometers east of Cape Hatteras, North Carolina. The periscope breaks the surface of the Atlantic at dawn, and through the lens, Captain Lieutenant Reinhold Hardigan watches his prey. The merchant ship is a British freighter, approximately 5,000 tons, sailing alone and unescorted, a straggler separated from its convoy during the night. The ship moves slowly through calm seas, oblivious to the predator stalking it from below. Hardigan's submarine, U-123, has been hunting in American waters for 3 weeks as part of Operation Drumbeat, and this will be his 7th kill of the patrol. Range, 1,200 meters, reports the targeting officer, his voice steady despite the cramped, humid air inside the U-boat's control room. The temperature inside the submarine is pushing 30 degrees Celsius. The smell is overwhelming, a mixture of diesel fuel, unwashed bodies, rotting food, and the metallic tang of recycled air. Hardigan has been at sea for 42 days. His crew of 48 men are exhausted, their faces hollow with fatigue, their uniforms stiff with salt and grime, but they are winning. In the first 3 months of 1942, German U-boats operating along the American East Coast have achieved results beyond even Admiral Karl Donitz's most optimistic projections. In January alone, they sank 62 merchant ships totaling 327,000 tons. February brought another 73 ships destroyed. March will exceed both previous months. The Americans, caught unprepared by Germany's declaration of war, have failed to implement convoy systems or adequate coastal defenses. Merchant ships sail independently, often with navigation lights blazing, silhouetted against the glow of American coastal cities that refuse to implement blackouts. The U-boat crews have taken to calling this period the second happy time, a turkey shoot where targets are abundant and opposition minimal. Tube 1 ready, announces the torpedo mate. Hardigan makes a final calculation: speed, heading, range. The torpedo will travel nearly a kilometer through the water, requiring precise prediction of where the target will be when the weapon arrives. He has done this dozens of times now. The mathematics are second nature. Fire Tube 1. The submarine shudders as compressed air forces the torpedo from its tube. Hardigan counts seconds, watching through the periscope as the torpedo's wake cuts across the surface toward the unsuspecting freighter. The weapon runs true. 45 seconds after launch, the torpedo strikes the merchant ship amidships, just below the waterline. The explosion is visible even at this distance, a column of water and debris erupting from the ship's side, followed by secondary explosions as cargo ignites. The freighter lists immediately. Hardigan watches through the periscope as crew members scramble across the tilting deck, launching lifeboats, diving into the water. The ship is going down fast, she'll be gone within 10 minutes. Hardigan records the details in his log: British freighter, 5,000 tons, cargo unknown, position 35 degrees 41 minutes north, 72 degrees 18 minutes west, sunk by single torpedo. Total for patrol, 7 ships, 41,000 tons. The mathematics of tonnage are everything in the Battle of the Atlantic. Germany's strategy is not to defeat the Allied navies in direct combat. The Kriegsmarine lacks the surface fleet to attempt such a thing. Instead, the strategy is attrition. Sink merchant ships faster than they can be replaced. Destroy cargo faster than it can be produced. Gradually strangle Britain's supply lines until the island nation is forced to negotiate peace. Donitz has calculated that if U-boats can sink 700,000 tons of Allied shipping per month, Britain will eventually collapse. In early 1942, German submarines are exceeding that target. As U-123 dives to avoid potential air patrols, Hardigan allows himself a moment of satisfaction. The war at sea is going better than anyone had predicted. American merchant marine losses are catastrophic. British cargo capacity is being destroyed faster than British shipyards can rebuild it. If this continues for another year, if U-boat production keeps pace with losses, and if the Allies cannot find effective countermeasures, Germany might actually win the Battle of the Atlantic. What Hardigan does not know, what no German naval officer can know in March 1942, is that across the Atlantic, in shipyards scattered along the American East Coast, West Coast, and Gulf of Mexico, a revolution in industrial production is beginning. American shipbuilders, under pressure to replace destroyed merchant tonnage, are developing techniques that will transform ship construction from a craft practiced in specialized yards to an assembly line process that can produce complete cargo vessels in weeks rather than months. The freighter Hardigan has just sunk required approximately 230 days to build, constructed by skilled craftsmen using traditional riveting techniques in a British shipyard that could produce perhaps 4 ships per year. The replacement ships that will soon flood the Atlantic will be built in 42 days, using prefabrication and welding, in American shipyards that will collectively produce 3 ships per day. Hardigan will learn this truth gradually over the next 2 years, as his patrol reports describe sinking merchant vessels only to encounter more merchant vessels on the next patrol, and then more on the patrol after that, until the mathematics of the Battle of the Atlantic shift from German advantage to Allied overwhelming superiority. But that understanding is still months away. For So now, in March 1942, Hardigan and his crew believe they are winning. They believe the Allies cannot replace ships fast enough. They believe the mathematics favor Germany. They are about to discover they are catastrophically wrong. September 1940. The Bethlehem Fairfield Shipyard, Baltimore, Maryland. 18 months before Hardigan's patrol, Henry J. Kaiser stands in the mud of what will become the largest shipyard on the East Coast and surveys a scene of organized chaos. Bulldozers are clearing land. Pile drivers are sinking foundation posts. Construction crews are erecting buildings that will house fabrication shops, assembly areas, and administrative offices. The noise is deafening, the clang of steel on steel, the roar of diesel engines, the shouts of foremen directing work crews. Kaiser is 58 years old, a self-made industrialist who has built dams, highways, and bridges across the American West. He has never built a ship in his life. That is about to change. Kaiser has been recruited by the U.S. Maritime Commission to help address what is rapidly becoming a national crisis. Britain is at war with Germany. British merchant shipping is being destroyed by U-boats at an alarming rate. Britain desperately needs replacement cargo vessels, not warships, but simple freighters that can carry food, fuel, weapons, and raw materials across the Atlantic. American shipyards are already operating at capacity, but capacity is nowhere near sufficient to meet British needs or to prepare for the possibility that America itself might enter the war. The problem is not just quantity but speed. Traditional shipbuilding is a craft industry dominated by skilled workers using techniques that have remained essentially unchanged for decades. Ships are built from the keel up, with each component custom-fitted and joined to adjacent components through riveting, a process where heated metal rivets are driven through aligned holes and hammered into place while still hot. Riveting requires skilled craftsmen who have trained for years. It is slow, labor-intensive, and produces ships that take 6 to 8 months to complete. Kaiser's background is in construction, not shipbuilding, and he approaches the problem as a construction challenge rather than a maritime craft. He has spent his career finding ways to accelerate large-scale projects through standardization, prefabrication, and innovative use of machinery. He looks at traditional shipbuilding and sees inefficiency everywhere. Too much custom work, too much waiting for sequential operations to complete, too much dependence on specialized skills. We're not building custom yachts, Kaiser tells the assembled engineers and naval architects during an early planning meeting. We're building cargo boxes that float. We need to build them the way Ford builds automobiles, with standardized parts, assembler line processes, and minimal skilled labor. The naval architects are skeptical. Ships are not automobiles. They operate in hostile environments where any structural weakness can be catastrophic. The ocean does not forgive poor craftsmanship. Traditional shipbuilding methods have evolved over centuries precisely because they produce vessels that are reliable and durable. Kaiser's proposals: using welding instead of riveting, prefabricating large sections off-site, employing unskilled workers trained in specific tasks rather than master craftsmen who understand the entire process, seem reckless to men who have spent careers in traditional shipyards. But Kaiser has something the skeptics lack: urgency backed by government contracts. The Maritime Commission has ordered 60 ships as an initial contract, with options for hundreds more if the concept proves successful. The ships will be built to a British design called the Ocean-class freighter, a simple, utilitarian cargo vessel of approximately 10,000 tons deadweight, powered by a triple expansion steam engine, capable of carrying tanks, trucks, aircraft, food, fuel, or any other cargo that can be loaded into its 5 holds. The American version of this design will be called the Liberty ship. The name is chosen for propaganda purposes. These vessels will carry the tools of freedom to Britain and eventually to Allied forces around the world. But the name also reflects what Kaiser and his engineers hope to achieve: liberation from the constraints of traditional shipbuilding, freedom to produce vessels in quantities and at speeds never before attempted. The key innovation is welding. Traditional ships are assembled by overlapping steel plates and joining them with thousands of rivets. This creates a strong structure but requires enormous labor. Welding, joining steel plates by melting their edges together with electric arcs, can be performed by workers with minimal training. A welder can join plates in minutes that would take a riveting crew hours. The process is faster, requires fewer workers, and potentially produces stronger joints than riveting. The problem is that welding in shipbuilding is largely unproven at the scale Kaiser is proposing. Welded seams can develop cracks if the steel is not properly prepared or if the welding technique is flawed. In 1940, most ships still use riveting for primary structural connections, with welding reserved for secondary elements. Kaiser is proposing to build entire ships primarily through welding, a radical departure from established practice. The second innovation is prefabrication. Instead of building ships sequentially from keel to deck, Kaiser's shipyards will fabricate major sections, entire hull sections, deck sections, superstructure components, in fabrication shops away from the shipways. These sections will be moved to the shipway only when ready for final assembly. This approach allows multiple sections to be built simultaneously, efficiency, dramatically reducing the time a ship occupies the shipway itself. It also allows work to proceed indoors in fabrication shops that are climate-controlled and better equipped than outdoor shipways. The third innovation is workforce training. Kaiser cannot find enough skilled shipwrights to staff his planned shipyards, so he creates training programs that teach workers to perform specific, limited tasks rather than comprehensive shipbuilding. A worker might learn only how to weld a specific type of joint, but learn to do it quickly and reliably. Another worker learns only how to operate a particular crane. Another learns only how to install a specific type of machinery. The ship is built by an army of semi-skilled workers, each performing a narrow task, coordinated by a smaller number of experienced supervisors. Critics call this approach dangerous. They predict that ships built by unskilled workers using unproven techniques will fall apart in storms or develop fatal structural problems. They warn that welding will produce brittle seams that will crack in cold Atlantic waters. They insist that there are no shortcuts in shipbuilding, that safety and reliability require traditional methods practiced by craftsmen who understand their trade. Kaiser listens to these criticisms, considers them, and proceeds anyway. He cannot afford to be cautious. The mathematics are clear. At current production rates, Allied shipping losses will exceed replacement capacity within months. If America enters the war, and by late 1940, that possibility seems increasingly likely, the demand for merchant shipping will increase exponentially. Traditional methods cannot scale fast enough. Innovation is not optional. It is existential. Construction of the first Liberty ship begins in early 1941. The keel is laid on April 30th. The ship is launched on September 27th, just 150 days later, already dramatically faster than traditional construction. The vessel is named SS Patrick Henry, after the Revolutionary War patriot. President Roosevelt attends the launch and makes a speech about American industrial capacity becoming the arsenal of democracy. But 150 days is still too slow. Kaiser's engineers analyze every step of the construction process, looking for inefficiencies, delays, bottlenecks. They redesign workflows. They improve training programs. They refine welding techniques. They expand prefabrication capabilities. Ship by ship, the construction time decreases. The second Liberty ship takes 140 days. The fifth takes 120 days. By early 1942, Kaiser's shipyards are approaching 100-day construction times. It is impressive progress, but it is still not enough. In the Atlantic, U-boats are sinking ships faster than even the accelerated American production can replace them. The Battle of the Atlantic is entering its most critical phase. And while Kaiser's innovations have improved shipbuilding efficiency, they have not yet achieved the revolutionary transformation that the crisis demands. That transformation is about to arrive. May 1943, U-56, North Atlantic, 800 kilometers west of Ireland. Captain Lieutenant Max Martin Teachet peers through the periscope at a sight that, 2 years ago, would have represented a U-boat commander's dream, a convoy of merchant ships stretched across the horizon, perhaps 40 or 50 vessels sailing in organized columns, each one a potential target worth thousands of tons. But Teachet is not excited. He is calculating odds that have become progressively worse with each patrol, and what he sees through the periscope is not opportunity but danger. U-56 has been at sea for 36 days. In that time, Teachet has managed to sink exactly one merchant ship, a straggler that had fallen behind its convoy during a storm. One ship, 6,000 tons. In early 1942, a successful patrol might account for 40,000 tons or more. Now, Teachet is risking his boat and crew for results that are, by historical standards, almost negligible. The problem is not lack of targets. The problem is that the convoys are now heavily defended. The merchant ships Teachet is watching are surrounded by escort vessels, destroyers, corvettes, and frigates equipped with sonar, radar, and depth charges. Aircraft patrol overhead, equipped with radar that can detect surfaced submarines even at night. The tactical situation has shifted from hunters stalking prey to predators attempting to penetrate sophisticated defenses while being hunted themselves. Escort vessels, bearing 090, reports the watch officer. Range approximately 5 kilometers. They are sweeping ahead of the convoy. Teachet watches the escorts through the periscope. The ships are following a standard search pattern, using sonar to detect submerged submarines. If U-56 approaches the convoy, the escorts will detect the submarine and attack with depth charges. If U-56 surfaces to use its deck gun or to reposition, aircraft will detect it with radar and attack with bombs or depth charges dropped from the air. The U-boat's traditional advantages, stealth, surprise, the ability to strike and escape, have been neutralized by technology and tactics that have evolved specifically to counter submarine warfare. But more demoralizing than the tactical situation is the strategic reality that Teachet and other U-boat commanders are beginning to understand. Even when they succeed, they are failing. Even if U-56 penetrates the convoy defenses, sinks 3 or 4 merchant ships, and escapes without being destroyed, an outcome that would be considered a brilliant tactical success, it changes nothing. The ships will be replaced within weeks. The cargo will be reshipped on other vessels. The strategic effect approaches zero. Teacher has been briefed on American production figures. He knows that American shipyards are now producing Liberty ships at rates that exceed total U-boat sinking capacity. He knows that the Allied merchant fleet is growing, not shrinking. He knows that Germany is losing the tonnage war. But knowing these facts intellectually is different from confronting them emotionally while staring through a periscope at a convoy that represents both temptation and futility. Diving officer, take us to 80 meters, Teacher orders. Silent running. U-56 sinks deeper into the Atlantic, moving slowly beneath the convoy, hoping to avoid detection by the escort vessel's sonar. The submarine will trail the convoy for hours, looking for an opportunity to attack. Maybe a ship will straggle. Maybe the escorts will be distracted. Maybe tactical circumstances will create a brief window of vulnerability. U-boat warfare in 1943 has become a game of patience, stealth, and accepting that opportunities are rare and success is unlikely. In the cramped control room, the crew works in silence. They understand the situation as well as Teacher does. They have heard the stories from other U-boat crews, boats lost with all hands, convoys that proved impossible to attack, patrols that returned without achieving any sinkings. The morale that had been so high during the happy time of 1940 to 41 and the second happy time of early 1942 has eroded into grim fatalism. U-boat crews now operate with the understanding that they are likely to die at sea, and that their deaths will not significantly alter the outcome of the war. The statistical reality is brutal. In 1943, German U-boat losses are accelerating. In May alone, this very month, the Kriegsmarine will lose 41 U-boats. In exchange, those U-boats will sink approximately 50 merchant ships. The exchange rate, from Germany's perspective, is catastrophic. Each U-boat represents months of construction, significant material resources, and a crew of 48 highly trained men. Each sinking is a loss Germany cannot easily replace. Meanwhile, American shipyards are producing 3 merchant ships per day. The mathematics are unsustainable. Admiral Donitz, confronting these losses, will temporarily withdraw U-boats from the North Atlantic later this month. The decision is presented as a tactical repositioning, but the reality is a strategic retreat. The U-boat campaign, which had come close to winning the Battle of the Atlantic in early 1942, has been defeated by a combination of improved Allied anti-submarine warfare and overwhelming American industrial production. But U-456 patrol is not yet complete. Teacher continues to stalk the convoy, looking for any opportunity. This is what U-boat commanders do. They persist, they take risks, they attempt the increasingly difficult task of penetrating defenses and sinking ships. They do this because it is their mission, because they are sailors following orders, because surrender to the inevitable is not part of their training. As U-56 moves beneath the convoy, Teacher allows himself a moment of dark reflection on what has been lost. In the early years of the war, U-boat crews had been heroes in Germany, celebrated in propaganda, respected by the public, treated as elite warriors. Now, in May 1943, they are casualties of an industrial war that Germany is losing. The submarine service has the highest casualty rate of any branch of the German military. 3 out of every 4 U-boat crew members will die in service. These are not odds that inspire confidence or hope. The periscope reveals what Teacher already knows: too many escorts, too much air cover, convoys that are too well organized and defended. He makes the decision that more and more U-boat commanders are making in 1943: withdraw, preserve the boat, return to base, live to patrol another day. Aggressive attacks in the face of overwhelming defenses are not courage, they are suicide. Helm, course 180, Teacher orders. We're breaking off. Take us away from the convoy. U-56 turns south, moving away from the convoy at slow speed to minimize noise. The crew breathes slightly easier. Another day survived. Another patrol that will return with minimal results. Another statistic in the larger story of how Germany lost the Battle of the Atlantic. Behind them, the convoy continues westward. 40 merchant ships, most of them Liberty ships built in American yards in 6 weeks or less, carrying tanks, trucks, aircraft, ammunition, food, and fuel to Britain. These ships will dock in Liverpool, Glasgow, and London. They will unload their cargo. They will take on ballast and return to America for more cargo. Most of them will complete dozens of crossings during the war. They are not just ships. They are the physical manifestation of American industrial capacity, the means by which raw materials and finished goods flow from American factories to Allied battlefields. For Germany, the sight of these convoys represents a strategic nightmare. No matter how many ships U-boats sink, more ships arrive. No matter how many cargoes are lost to the Atlantic, more cargoes are shipped. The industrial base that produces these ships is beyond the reach of German military power, protected by thousands of miles of ocean, producing at scales that Germany cannot match or counter. Teacher does not know that historians will later identify May 1943 as the turning point of the Battle of the Atlantic, the month when U-boat losses became unsustainable and German naval strategy effectively collapsed. He knows only that this patrol, like recent patrols before it, has demonstrated the futility of what he is attempting to accomplish. He will write this in his patrol report with careful diplomatic language that avoids outright defeatism but makes the strategic situation clear to anyone who reads between the lines. U-56 will survive this patrol and return to port. Teach-it will survive the war, but the U-boat campaign will not. The flood of ships pouring from American yards has drowned German hopes as surely as depth charges have destroyed U-boats. 1944-1945. The final accounting. By the end of 1943, the statistical reality of the Battle of the Atlantic is undeniable. American shipyards have delivered 2,710 Liberty ships since the first keel was laid in 1941. British yards have produced hundreds of additional cargo vessels. Canadian shipyards contribute their own output. The aggregate Allied merchant fleet is larger at the end of 1943 than it was at the beginning of 1942, despite 2 years of sustained U-boat attacks. Germany has lost the tonnage war decisively and irreversibly. The production continues through 1944 and 1945. Liberty ships pour from American yards at rates that remain consistently near 3 ships per day. Some months exceed this average, some fall slightly below, but the overall trend is relentless. American industrial capacity, once fully mobilized and optimized, produces merchant shipping at scales that have no historical precedent and will never be matched in peacetime. By war's end in August 1945, the United States will have completed 2,710 Liberty ships. This represents approximately 27 million tons of cargo capacity, more than 3 times the entire American merchant fleet that existed in 1941. The construction employed hundreds of thousands of workers, consumed millions of tons of steel, and cost approximately $4 billion. It is one of the largest industrial projects in human history, comparable in scale to the Manhattan Project or the construction of the interstate highway system. But unlike those projects, Liberty ship construction received relatively little public attention during the war. The ships were utilitarian, unglamorous, and their significance was primarily logistical rather than dramatic. Newspapers reported on battles and bombing raids. They did not typically report on the third Liberty ship launched from a California yard on a Tuesday in March 1944. Yet those ships, in aggregate, were as decisive as any military campaign. The Liberty ships made possible every Allied military operation from 1943 onward. When American forces landed in Normandy in June 1944, Liberty ships had carried their equipment across the Atlantic. When Soviet forces received American trucks, food, and weapons through Lend-Lease, Liberty ships had delivered them through Arctic convoys to Murmansk. When British forces advanced across North Africa and into Italy, Liberty ships sustained their logistics. When American forces island-hopped across the Pacific, Liberty ships carried the fuel and ammunition and supplies that made each operation possible. The ships also carried less dramatic but equally essential cargo, wheat to prevent famine in Britain and the Soviet Union, raw materials to keep Allied factories operating, medical supplies to treat wounded soldiers, coal to heat British homes during winter. The ships were the logistical infrastructure that sustained Allied nations through years of total war. From Germany's perspective, the Liberty ships represented the visible manifestation of why Germany could not win a prolonged war against the United States. German industry could produce quality weapons, excellent tanks, aircraft, submarines, but German industry could not produce them in quantities that matched American output. A German shipyard might build a U-boat in 8 months. An American shipyard could build 3 Liberty ships in the same period. A German factory might produce 50 tanks per month. American factories produced 2,000 tanks per month. The qualitative superiority of German weapons was overwhelmed by quantitative inferiority in production capacity. Admiral Donitz, in his memoirs written after the war, acknowledged that the U-boat campaign had been defeated primarily by American shipbuilding capacity. German submarines had sunk over 2,800 Allied merchant ships during the war, a staggering toll. But American and Allied shipyards had produced over 5,000 merchant ships in the same period. The mathematics were inescapable. Germany could not sink ships faster than America could build them. The irony is that the Liberty ships were not particularly good ships by traditional standards. They were slow, maximum speed of 11 knots, slower than many U-boats operating on the surface. They were crude in construction, lacking the refinement of peacetime merchant vessels. They had significant design flaws, some developed cracks in their welded hulls, particularly in cold weather, and a few suffered catastrophic failures where hulls literally broke in half during storms. These failures led to design modifications and improved welding techniques, but they confirmed the concerns of traditionalists who had warned that mass production would compromise quality. Yet despite these flaws, the Liberty ships accomplished their mission. They were good enough. They carried cargo reliably across dangerous waters. They were produced produced in quantities that overwhelmed enemy opposition. They could be built faster than they could be destroyed, and that was sufficient. The perfect was not the enemy of the good enough. The good enough, produced in vast quantities, achieved what perfection in small quantities could never accomplish. Henry Kaiser, the industrialist who had revolutionized shipbuilding, emerged from the war as one of America's most celebrated business leaders. He had proven that traditional industries could be transformed through systematic analysis, standardization, and willingness to challenge conventional wisdom. His methods, prefabrication, welding instead of riveting, assembly line production, training of semi-skilled workers, became standard practice in post-war shipbuilding and influenced manufacturing across multiple industries. The Liberty ships themselves had varied post-war fates. Many were scrapped immediately after the war, their hulls worn out from years of hard service. Others were sold to private shipping companies and continued in commercial service for decades. Some were converted to other purposes, grain storage vessels, floating warehouses, even floating hospitals. A handful were preserved as museum ships, monuments to the industrial achievement they represented. One Liberty ship, SS John W. Brown, continues to operate today as a museum ship in Baltimore, maintained by volunteers and occasionally taken on cruises where passengers can experience what it was like to sail aboard these vessels. Visitors can tour the cargo holds, engine room, crew quarters, and bridge. They can see the simple, functional design that allowed the ships to be built so quickly. They can understand, perhaps for the first time, that these ugly, utilitarian vessels were instruments of strategic victory as important as any battleship or bomber. The lesson of the Liberty ships extends beyond World War II. They demonstrated that industrial capacity, properly organized and applied, can overcome military challenges that appear insurmountable through conventional means. They showed that speed of production can be as important as quality of product. They proved that civilian industrialists, given clear objectives and adequate resources, can solve problems that military experts consider impossible. Most importantly, they revealed a fundamental truth about modern warfare. Wars between industrial nations are won not just on battlefields but in factories, shipyards, and assembly plants. The side that can produce more ships, more tanks, more aircraft, more ammunition, that side possesses an advantage that tactical brilliance alone cannot overcome. Germany had capable soldiers, innovative tactics, and high-quality weapons. But Germany could not match American industrial production. And in a total war where both sides were mobilizing every resource, industrial capacity became the decisive factor. The U-boat crews who had sailed in 1942 believing they were winning the Battle of the Atlantic had been correct in their tactical assessments. They were sinking ships faster than traditional shipyards could replace them. What they could not anticipate, what perhaps no one could have anticipated before witnessing it, was that American industry would revolutionize shipbuilding itself, transforming it from a craft into a mass production process that could build complete cargo vessels in 6 weeks. By the time U-boat commanders understood what was happening, it was too late. The flood of ships had begun, 3 per day, every day, for years. Steel hulls carrying tanks and trucks and ammunition and food across the Atlantic in convoys so large that sinking a few vessels meant nothing. An industrial tsunami that drowned German strategic plans as thoroughly as depth charges destroyed U-boats. In the end, Germany's submarine campaign failed not because U-boats weren't effective weapons, they were highly effective. The campaign failed because effectiveness became irrelevant when the enemy could replace destroyed ships faster than you could destroy them. The Battle of the Atlantic was won not by superior naval tactics but by superior industrial organization. And the Liberty ships, those crude, ugly, rushed into service cargo vessels, were the instruments of that victory. November 12, 1942. Richmond Shipyard No. 2, California. At 12:01 a.m., under floodlights that turn night into harsh artificial day, the keel of Liberty ship hull No. 440 is laid on ways No. 1. The steel plate, pre-cut, pre-drilled, marked with chalk lines indicating where welds will be placed, is lowered into position by a massive overhead crane. Welders move in immediately, their arc torches flashing blue-white as they begin joining the keel plate to foundation supports. The ship that will become SS Robert E. Peary has begun its journey from raw steel to completed vessel. The Richmond shipyards, located on San Francisco Bay and operated by Kaiser's construction company, have become the most productive shipbuilding facility in the world. What was marshland 18 months ago is now an industrial complex covering hundreds of acres, employing over 90,000 workers across 4 separate shipyards, operating 3 shifts per day, 7 days per week. The yards never stop. As one ship is launched, another keel is laid on the same slipway. The rhythm is constant, mechanical, an assembly line producing 10,000-ton cargo vessels the way Detroit produces automobiles. But what is about to happen on ways No. 1 over the next few days is not routine production. It is an experiment, a demonstration, a challenge to prove that everything Kaiser's engineers have learned about rapid ship construction can be pushed to an absolute limit. The goal is not just to build a ship quickly. The goal is to build a ship faster than anyone has ever built a ship before, to set a record so extraordinary that it will demonstrate beyond any doubt that American industrial capacity has achieved something historically unprecedented. Joseph "Red" McCarthy, the WWII superintendent, has been planning this record attempt for weeks. McCarthy is 34 years old, a former ironworker who has risen through Kaiser's organization on the strength of his ability to organize complex construction operations. He stands on the shipway with a clipboard, a stopwatch, and a radio that connects him to every section of the yard. Around him, work crews are already moving into position: welders, riggers, pipe fitters, electricians, machinists. Everyone involved understands what is at stake. This is not just another ship. This is proof of concept. The construction follows a carefully choreographed sequence. While the keel is being laid, prefabricated hull sections are being moved from fabrication shops toward the shipway. These sections are enormous, some weigh over 200 tons, and have been constructed over the previous weeks in enclosed buildings where conditions can be controlled. Each section includes not just hull plates but internal framing, piping, electrical conduits, and even some machinery. The sections arrive at the shipway essentially complete, requiring only to be welded together and connected to adjacent sections. By 6:00 a.m. on November 12th, the first hull sections are being lowered into place. Cranes position them with precision measured in inches. Welders work in teams, racing along seams, laying down continuous beads of molten metal that join sections together. The sound is deafening: the crackle of welding torches, the clang of hammers, the hiss of steam, the shouts of foremen, the mechanical growl of cranes and locomotives moving materials. Kaiser himself is present for the record attempt, moving through the yard, observing, encouraging workers, conferring with supervisors. He understands that this is more than an engineering exercise. This is psychological warfare. If American shipyards can build a Liberty ship in less than a week, if they can demonstrate construction speeds that make U-boat sinkings essentially irrelevant, then German naval planners will understand that they have already lost the Battle of the Atlantic. The mathematics will be undeniable. The pace is extraordinary. Hull sections are joined at a rate of one every few hours. By the evening of November 12th, barely 20 hours after the keel was laid, the basic hull structure is taking recognizable shape. Deck sections are being positioned. The stern post is installed. Engine room components are being lowered into place through openings in the deck that will later be sealed. The prefabrication strategy is proving its value. The ship's superstructure, the deck house containing crew quarters, galley, and bridge, arrives as a single pre-assembled unit. It is lifted by crane and positioned on the main deck. Welders immediately begin securing it. Electricians connect pre-routed cables. Plumbers connect pre-installed piping to the ship's main systems. Work that would traditionally require weeks of on-site construction is completed in hours. By November 14th, just 3 days after construction began, the ship is visibly approaching completion. The hull is fully assembled. The superstructure is attached and secured. The main engine, a massive triple-expansion steam engine pre-assembled in a separate facility, has been installed. Boilers are in place. The propeller shaft is aligned and secured. The rudder is mounted. Essentially all of the major structural work is complete. The final 2 days are devoted to finishing work, installing auxiliary equipment, completing electrical systems, testing machinery, painting, loading supplies, preparing for launch. Workers swarm over the vessel in organized chaos. Every trade is represented: welders completing final seams, electricians testing circuits, painters covering steel with coats of gray paint, riggers installing cargo handling equipment, provisioners loading food and supplies. On November 15th, 4 days and 15.5 hours after the keel was laid, SS Robert E. Pei is ready for launch. The ship is complete in every essential respect. It has functioning engines, working electrical systems, operational pumps and steering gear, crew quarters ready for occupancy, and cargo holds ready to receive cargo. It is not a hull or a partial construction. It is a finished vessel capable of crossing the Atlantic. The launch occurs at 3:30 p.m. on November 15th. Champagne is broken across the bow. The restraining blocks are knocked away. The ship slides down the slipway into San Francisco Bay, displacing thousands of tons of water, floating free for the first time. A crowd of shipyard workers, journalists, military observers, and government officials witnesses the launch. They are watching history being made, a ship constructed in 4 days, 15 hours, and 30 minutes. It is a record that will never be broken under peacetime conditions. But the significance is not primarily about the record itself. The significance is what the record demonstrates about American industrial capacity. If a single shipyard can build a complete Liberty ship in less than a week under optimal conditions, then shipyards operating under normal production schedules can build Liberty ships in 6 weeks, 5 weeks, perhaps even less as techniques continue to improve. And if America has dozens of shipyards all building Liberty ships simultaneously, then the production rate becomes almost unimaginable. The mathematics are devastating to German strategic calculations. In the time it takes a U-boat to complete one patrol, approximately 6 weeks from leaving leaving port to returning, American shipyards are now producing more tonnage than the entire U-boat fleet can sink in that same period. The attrition warfare strategy that appeared to be working in early 1942 is being overwhelmed by industrial production that operates at a scale Germany cannot match. Admiral Donitz, receiving intelligence reports about American shipbuilding rates, initially dismisses them as propaganda or exaggeration. The numbers seem impossible, but as months pass and U-boat patrol reports consistently describe encountering more merchant shipping rather than less, the truth becomes undeniable. America is not just replacing destroyed ships. America is adding to the total merchant fleet faster than U-boats can reduce it. The Battle of the Atlantic, from Germany's perspective, is being lost not through tactical defeats but through industrial superiority. The SS Robert E. Peary completes sea trials and enters service in December 1942. She will make several successful Atlantic crossings, carrying cargo to Britain and North Africa. Her construction time remains a record, but more importantly, her existence proves that everything Kaiser has proposed about revolutionary ship construction is achievable. The techniques used to build her rapidly will be refined and incorporated into routine production across all American shipyards building Liberty ships, and the production numbers will continue to climb. 1943. Shipyards across the United States. By January 1943, the transformation of American shipbuilding from craft industry to mass production is complete. 18 major shipyards on the East Coast, West Coast, and Gulf of Mexico are producing Liberty ships simultaneously. The Maritime Commission has standardized every aspect of production: blueprints, materials specifications, quality control procedures, training programs. A worker trained in welding techniques at a Baltimore shipyard can transfer to a California shipyard and perform the same job with the same methods. Parts fabricated in one location can be shipped to another location and will fit perfectly because tolerances are standardized. The production statistics for 1943 are staggering. In January, American shipyards deliver 56 Liberty ships. In February, 67 ships. In March, 81 ships. The monthly production continues to climb through spring and summer. By mid-1943, the United States is completing an average of 3 Liberty ships per day, 140 ships per month, more than 1,600 ships for the entire year. Each ship carries approximately 10,000 tons of cargo. The aggregate capacity being added to the Allied merchant fleet is approaching 16 million tons per year. To understand the scale of this achievement, consider that in 1941, the entire American merchant marine totaled approximately 8 million tons. In a single year, 1943, American shipyards are producing double the tonnage of the entire pre-war merchant fleet. The industrial capacity is not just replacing losses, it is fundamentally altering the mathematics of naval warfare. At the Kaiser Richmond shipyards, the assembly line approach has been refined to near perfection. Each of the 4 separate yards operates 6 shipways. Ships occupy the ways for an average of 42 days, down from the 150 days required for the first Liberty ship less than 2 years earlier. When a ship is launched, the way is immediately prepared for the next keel. The cycle is continuous. The yard is producing 1 ship every 7 days from each way, approximately 24 ships per month from the 4 yards combined. The workforce has expanded to accommodate this production. Over 90,000 people work at Richmond, including thousands of women who have entered industrial trades for the first time. Rosie the Riveter has become a cultural icon, though the reality is that most of these women are welders, not riveters. Welding has almost completely replaced riveting in Liberty ship construction. The women prove as capable as men at performing the specialized tasks required for assembly line shipbuilding, and their entry into the workforce helps solve the labor shortage that threatened to limit production. The training programs have evolved into sophisticated systems. New workers attend classes for 1 to 2 weeks, learning specific skills: welding, crane operation, pipe fitting, electrical installation. They practice on training mock-ups that replicate actual ship sections. By the time they enter the shipyard, they can perform their assigned tasks competently if not expertly. Experience comes with repetition. A welder who joins 50 seams becomes proficient. After 500 seams, the welder is expert. And in a shipyard producing ships continuously, workers accumulate that experience rapidly. Quality control is rigorous. Every weld is inspected. Random sections are X-rayed to detect internal flaws. Completed ships undergo sea trials where machinery is tested under operating conditions. Defects are identified and corrected. Ships that do not meet standards do not enter service until problems are resolved. The early concerns that mass production would produce unreliable vessels prove largely unfounded. Liberty ships are not elegant, they are utilitarian, crude by peacetime standards, designed for functionality rather than comfort or aesthetics, but they are seaworthy and reliable. The ships are also being produced at costs that traditional shipbuilding could never achieve. The first Liberty ships cost approximately $2 million each. By 1943, with production fully optimized, the cost cost has dropped to approximately $1.5 million per ship. This reduction comes from economies of scale, improved efficiency, and learning curve effects where workers become more productive with experience. The cost per ton of cargo capacity has dropped to levels that make Liberty ships essentially disposable in economic terms. If a Liberty ship makes one successful Atlantic crossing, it has paid for itself in the cargo it delivered. Across the Atlantic, in the concrete bunkers where German U-boat operations are coordinated, Admiral Karl Donitz confronts the implications of American production. Donitz's staff has compiled intelligence reports, analyzed patrol logs, and calculated Allied merchant tonnage losses versus construction rates. The conclusion is unavoidable: U-boats are losing the tonnage war. In 1942, U-boats sank approximately 6 million tons of Allied shipping. In 1943, despite having more U-boats at sea than ever before, sinkings are declining while Allied merchant tonnage is increasing. American shipbuilding has overwhelmed the U-boat campaign. Donitz is a capable naval officer who understands mathematics. His entire strategy has been based on the calculation that if U-boats sink 700,000 tons per month, Allied logistics will collapse. For a brief period in early 1942, that target was achieved. But now, in 1943, American production alone is adding 1.3 million tons per month to Allied merchant capacity. Even if every U-boat sinks its maximum possible tonnage, and Allied anti-submarine warfare is making that increasingly difficult, German submarines cannot sink ships faster than American shipyards build them. The psychological impact on U-boat crews is profound. Captain Lieutenant Reinhard Hardigan, who had achieved remarkable success during the second happy time of early 1942, returns from a patrol in late 1943 and reports to Donitz that the number of merchant ships in the Atlantic appears to have increased rather than decreased. Other commanders report similar observations. It is dispiriting to risk your life, achieve tactical success by sinking merchant vessels, and then encounter more merchant vessels on your next patrol than you encountered on your previous patrol. The Battle of the Atlantic is turning decisively in favor of the Allies. This shift is due to multiple factors: improved anti-submarine tactics, better convoy systems, long-range aircraft that can patrol mid-Atlantic gaps, advances in radar and sonar technology. But underlying all of these factors is the fundamental reality of industrial production. Even if German U-boats were operating with perfect effectiveness, even if Allied anti-submarine measures were completely ineffective, American shipyards are producing merchant tonnage faster than U-boats can sink it. The mathematics have shifted irreversibly. By the end of 1943, the United States has delivered 1,928 Liberty ships into service. Britain has launched hundreds of additional cargo vessels. The combined Allied merchant fleet is larger in 1943 than it was in 1941, despite 2 years of sustained U-boat attacks. German hopes of strangling Allied supply lines through submarine warfare have been defeated not by naval tactics but by industrial production. The Liberty ships are crossing the Atlantic in convoys of 50 or more vessels, escorted by destroyers and aircraft. They carry tanks, trucks, aircraft, ammunition, food, fuel, everything needed to sustain Allied forces in Europe, North Africa, and the Pacific. They are the logistical foundation for every Allied offensive. When American troops land in Sicily in July 1943, Liberty ships have carried their equipment. When British forces advance across North Africa, Liberty ships have supplied their fuel. When Soviet armies receive American trucks and food through Lend-Lease convoys, Liberty ships have delivered them through Arctic waters to Murmansk. The ships are not glamorous. They do not win battles directly. Sailors who serve on them face constant danger from U-boats, storms, and the general hazards of ocean transit in wartime. But the Liberty ships are, in aggregate, as decisive as any weapon system in World War II. They are the means by which American industrial capacity is translated into military power on battlefields thousands of miles from American shores. And they are still being produced, 3 per day, every day, in a flood of steel that is drowning Germany's hopes of victory through attrition warfare.